How you doing? This is a quick little tutorial on basically, this should say mini spec. Sorry. This should say how do we tell if something is polar or not. So I apologize for that little typo, but I will have this PDF. The first thing I would do is actually download this PDF, which I'll have down in the notes. So it's like guided notes. Basically, if you're given a covalent compound, how do we tell if it's polar or not polar? We're going to look at some basic steps. The flow chart is one of the most important pieces. You'll have to do the Lewis dot structure first in every single case. Once you do that, can you tell the types of bonds if you use an electronegativity chart? There's only three choices: non-polar covalent in character, polar covalent character, or ionic in character. And then we'll have to look at the symmetry and the shape of the compound, and then hopefully come up with a final answer. Is it polar or non-polar? So this is just sort of meant to be as a guide and a little bit of a tutorial. Okay, so first of all, this right here is one of the most important pieces right here. And you'll have to know this, and it might look complicated. You can pretty much ignore this part here, but here's the basic idea. You have to draw the Lewis dot structure first. Once you do that, take a look at this is always the first step. Then take a look at the types of bonds that are present with the changes in electronegativities. If it's an ionic compound, which is metals, nonmetals, or there are no polar bonds or ionic in character. So again, if it's an ionic compound or it's all like nonpolar covalent, you're done. That means you're pretty much over here. It's either not polar or it's an ionic compound, which is a whole separate issue. If, however, you draw the Lewis dot structure, there's one bond, and all it takes is one, that's polar covalent or ionic in character. We're dealing with nonmetals, nonmetals. Then we start to have to go over to this side of the chart. We'll take a look at the shape. Is it symmetrical or not? And then it'll be able to identify it's polar or non-polar, and that's going to determine properties, which is huge. Okay. So first step, Lewis dot structure. If there are no polar bonds in the molecule, covalent, no polar, non-polar, covalent, you're done. It's a non-polar molecule. Okay, so that's, and if it's ionic, it's a whole separate issue. Okay. Okay, so first step is Lewis dot structure. I thought we would do an example. This is CH2Cl2. I think it's called methylene chloride. And it's just carbon in the center. We have chlorines over here, and the H is over here. And so again, according to our flow chart, which I see I can get back to, according to our flow chart, we have to use the change in electronegativities to figure out what are the bonds doing. Okay, and so if I look at this, what types of bonds are there? Well, I can see there's only really two types of bonds: carbon and chloride, or chlorine bonds, carbon chlorine, or carbon and hydrogen. Using this guide that we have right here, the carbon and hydrogen bonds look like they're nonpolar covalent. So a portion of this is nonpolar, but carbon chlorine is above that 0.4. This would definitely be a polar covalent bond here, and a polar covalent bond here as well. And so that's all. You just need to find one. As long as you find one, it could be a polar compound. We don't know for sure yet. Okay, so if we go back and look, sorry about that. If we go back and look, we've looked at the electronegativities. We've done Lewis dot structure. We looked at the electronegativities. Hey, guess what? There's at least one bond that's a polar covalent bond, the CCl bond. Let's go further. Okay, so if we go further, the next one is it symmetrical? Now this one is where we kind of need to know what the shape is. Okay, we've at this point, hopefully we've talked about shapes. Here's the simplest way I can break this down. If around the central atom, okay, which is the carbon, around the central atom, if you see any like lone pairs of electrons, it is not symmetrical. Or if there are different groups around the central atom, usually it's not symmetrical. So what do I mean by that? Well, if we look here, carbon's the central atom. Uh, the things around the central atom are different. So this is like chlorine, H and H. It looks like if you put a line through here, you could get one side that's the chlorine, one side that's the H's. It's not really a mirror image. That would be considered unsymmetrical. Okay, so again, if it has lone pairs of electrons or different groups around the central atom, usually 99.9% of the time, it's not symmetrical. So again, going back, we've decided, okay, drew the Lewis dot structure, change in electronegativity. We know there's a polar covalent bond. We can find the shape. And is it symmetrical? No. So therefore, it's probably a polar molecule. Now, just to show you this, what happens if it is symmetrical? Okay, now these are all polar bonds, but they're all pulling in exactly the same way, so they cancel out. So there's a really important term we use. I would definitely write this down. Symmetry cancels polarity. So even if I have a bunch of polar bonds, but the molecule is incredibly symmetrical, the symmetry of the molecule cancels the fact that there are these polar bonds. The molecule is non-polar, even though there are polar bonds. Now, one of the really cool things we can do with Atom Smith is we can click a button that says, show me the dipole. If what I'm saying is right, this over here should show no dipole, and yet this one should, right? So let's look. And if we look, sure enough, symmetry and cancels polarity. This has polar bonds. It's not symmetrical. We definitely see it's trying to show us with this that one side is kind of negative. The more electronegative chlorines are pulling things down on the electrons. One side's kind of positive. Over here, no dipole, right? And so it's something we can check. Now, you'll have to do this without the help of Atom Smith, but Atom Smith is nice. You just click on that button and it'll show you the dipoles. So just to review real quick, first step in determining if something's polar, you have to determine the Lewis dot structure. Second, what types of compounds or bonds are there? If there's all non-polar covalent bonds, you're done. The whole thing is non-polar. If there's ionic bonds, metal nonmetals, that's a whole separate issue. If it's a covalent compound with one polar bond, just one polar bond, we then have to say, okay, what's the shape? If it's not symmetrical, it's going to be polar. If it is symmetrical, symmetry cancels polarity. Okay. Hope this helps. Make sure you take notes. Have a great day.